Understanding chemical bonding is vital to any meaningful understanding of chemistry and everything that's related to it. Lewis dot structures, again, are a cornerstone. So the question is, why is the bonding of Lewis dot structures based on the octet, based on 8? Well, Lewis at the time didn't actually have the answer to that. It wasn't until with Schrodinger and his quantum numbers that we essentially derived the orbitals. We have the s orbital, px, py, pz, z. Okay, so these 4 orbitals each holds 2 electrons. So 2, 4, 6, 8. That's where this magic number of 8 comes from. But there's a huge catch to this. This octet rule fails a lot. Why? Well, because we have other orbitals. We have the d orbitals. And there are other aspects of chemical bonding that Lewis dot structures don't take into account. So it's very important to understand Lewis dot structures and to be able to draw Lewis dot structures without difficulty, because again, it's one of those things where if you're a little rusty. But if you remember from general chemistry, you had things like odd electron species, electron deficient species, things that had less than an octet. You had species that had more than an octet, called an expanded octet, which again is a terrible name, but it is what it is. And we're going to see that there's lots and lots of flaws to the octet rule, but it's a good starting point. For elements like carbon, nitrogen, oxygen, the P block, the main group elements, the octet rule usually works very, very well. Organic chemistry is mostly based on the octet rule. But we're going to find that it fails. Now again, to answer this question, px, py, pz, 4 atomic orbitals, and each one holds 2 electrons, therefore 8 electrons to get to the octet.